Welcome to solverfy.
This is the answer to Chapter 16, problem number 5 from the Smith Organic Chemistry textbook. And this problem asks us to draw additional resonance structures for each of the 4 ions that were given in the problem. And so in order to do that, we are going to move electrons. And so for A, we can draw 2 more resonance structures. So the first one, the electron movement, would look like this. So this lone pair can add in here. These electrons can go to this carbon. And so our first resonance structure is going to be this. So single bond here now, a double bond here now, and our lone pair and negative charge are now located on this carbon. And so we can also go the other way. So these electrons can add back in here. These electrons can go here. And these electrons can go to this carbon. And so the result of that electron movement is going to be a resonance structure where we have a double bond here, a single bond here, a double bond here, and a single bond here with the lone pair and the negative charge on this terminal carbon. Okay, so then for B, we can do the exact same thing. So our lone pair can add in here. These electrons can go to the oxygen. And so that is going to give us our only resonance structure here, where the oxygen has a single bond to the carbon, and there is a carbon-carbon double bond here now. And this would be considered a more stable structure. We do always want to put extra electrons and charges on electronegative atoms, and oxygen is more electronegative than carbon is. Okay, so that's B. So then for C, we can have one of the lone pairs on this chlorine add in here, and the result of that is going to be the single resonance structure that we can draw here. And so when we do this, our chlorine is now doubly bound to the carbon and only has 2 lone pairs. And so it's going to have the positive charge on it. But again, it's always better to put positive charges on electronegative atoms. So that looks fine. So then for D, we're going to be able to draw 2 resonance structures here. And they're both going to be just movement of electrons, as always. And so the first thing we can do is move these electrons over that double bond. And so that's going to give us our first structure, which is going to look like this. Okay, and so our positive charge is now on this carbon. And then we can also move these electrons to here. And so that's going to give us a resonance structure where our positive charge is on the ring, and we have double bonds here and here. And so this would also be a good resonance structure because you can see we now have 3 double bonds that are conjugated in this system. So that's good. Okay, and so that's the answer to this problem. Again, the way to draw resonance structures is just to move electrons. Nothing else about the molecule changes. And sometimes as a result of the electrons moving, charges will move as well. But really the way to visualize this is just movement of electrons. And that's the answer to chapter 16, problem number 5.